Thanks for joining us, Troy. Tell the CBC family a little bit about yourself and what you do as a job or career.
Yeah, thanks. It's no problem being here, Jeff. So I am a chemistry teacher at Hempfield High School. It is a public school that's not too far from here. Some of the families at CBC live in Hempfield. And been teaching chemistry there for a while, and I have an interest in apologetics. I have an interest in learning the background of how do we know that Christianity and those beliefs are true.
Well, it's a pretty cool opportunity for you to be able to be a Christian and teach chemistry at a local public school. So this morning, I've been sharing with the CBC family how creation gives evidence and points to the fact that there's a creator, that there's a God. And one of the arguments is what's known as the fine-tune argument. Can you share a little bit about what that argument is? And then maybe later we'll have you share some of the examples.
Yeah, sure. So first of all, the fine-tuning argument, it's what sometimes is referred to as the Goldilocks principle. Whereas if things were left to random chance, it could be a lot like this, or too much like this, or it could be too much like that. And the way it turns out is that it's just right. Just like the story of Goldilocks. And so, and the fine-tuned argument, not only that, but that is the argument that atheists, when they've been asked, what's the best argument for someone from the other side who's arguing for Christianity, what's the best argument on that side? And they scratch their heads and like, man, the fine-tuned argument, we can't come up with an answer for that, because if you take away all of the philosophy, it looks like somebody planned this out.
Mm-hmm. So what are some of the examples that you point to that shows and points to the fact that there's a designer, that there's a creator, that somebody has planned out this world we live in?
So full disclosure here, some of these things I'm about to tell you about, I knew about them beforehand, but I recently read a book that there was several chapters devoted to this, and I read through that again after we talked, and I was making notes about it. So this isn't just off the cuff here from me. So there are several things that are specific about our planet. The first thing is how big the Earth is. So in the solar system, there are planets that are smaller than us, there are planets that are larger than us, and Earth is just the right size. If it was smaller, then there's this magnetic field around the Earth that protects us from the sun. And if it was smaller, then that magnetic field wouldn't be strong enough. And things would have been wiped clean from the radiation from the sun. And there are planets in the solar system that are like that. There's no life on them. And if our planet was larger, then our gravitational field would be stronger, and that would kill life in other ways that the things would be crushed. They wouldn't have formed the way they have. So just the size of our planet, it's just the right size. And another thing, how far away our planet is from the sun. Everything on Earth that deals with life is based on water. And if our planet was closer to the sun, then we'd be too hot. And the water would have boiled away, and there's no water left. And if we're too far away from the sun, then it would have been too cold. And everything would have frozen up, and there'd be no life. So those two things, just from the get-go, those are fairly easy for lots of people to imagine, at least especially the distance part, that, oh, hey, wow, it's pretty cool that our planet is just in the right location.
That's the Goldilocks. Not too hot, not too cold.
Exactly.
Just right.
It's just right.
Fine-tuned.
Yeah. So in addition to how far we are from the sun, in the solar system, there are other things that are set up that make life possible. And one of them is that farther from the sun, there are these things called gas giants. And so the planets in our solar system that are gas giants, they're Jupiter and Saturn. They're massive planets, and they have a lot more gravity than we do. And gravity pulls things in. And so they're running interference on our behalf. So we're in the middle part of the solar system. Jupiter and Saturn are way out here, and when asteroids come into our solar system, when comets come into our solar system, they get snapped up by those big planets, and we are protected. And there have been some movies made about what happens if an asteroid or something might hit our Earth. Catastrophic consequences. A little over 100 years ago, an asteroid, I don't know if it hit Siberia, but it came close to it. It exploded maybe not far up in the atmosphere. And millions of trees were leveled by the impact. And we're safe from that. There have been spectacular video that was caught of comets hitting Jupiter and Saturn and stuff, but we are blessed in ways we don't know because of those gas giants out away running interference for us. That's our location in the solar system. Mm-hmm. Our location in the galaxy is also beneficial for us. So we're in the Milky Way, which is our galaxy, is a spiral galaxy, and we are on one of the tails. If we were closer in to the middle of the galaxy, picture a spiral galaxy as a pinwheel. Mm-hmm. If we were closer in, then there would be a whole lot more stars, and stars are giving off radiation, okay? Sit out in the sun too long, and you get burned. Well, if we were closer into the middle of the galaxy, there'd be a lot more stars, and we would be bombarded with radiation many times more than what we get here on Earth, and it would not be possible for life to be there.
So the precision of where the Earth is,
yeah,
in terms of the galaxy, is also just right.
Yeah, and these are all things that it's obvious that we have no control over this.
Right. And without it being fine-tuned or just the way it is, there would be no possibility for life.
Oh, right. And sometimes people criticize the Christians are like, well, of course things have to be right for life because we're here. But it's only been in the last few years that we've been able to, and I don't fully understand how these measurements have been made, but it's only been in the last few years that we've been able to make measurements of, oh, if we were someplace else, then this would happen and we wouldn't be here. Right. So it's not that it's not possible for life, but we're here. It would be not possible for life and we wouldn't be here.
Right.
So one thing about the universe, everything that there is, the universe is expanding. We've only known that for less than 100 years. It's important that it is, because if it wasn't, then it'd be possible the universe was eternal. If the universe was eternal, then we start to wonder, well, wait a minute, if there's enough time, then the evolutionists step up and oh, yes. If there's enough time, then anything can happen. But the universe is expanding, and that means that at one time it was smaller than it is now, and you can keep going backwards. It was smaller, it was smaller, it was smaller. At one time it didn't exist. And so God created everything, and the universe is expanding outward. And then there are several things that are fine-tuned just in the way that things are moving farther apart from each other. So the density of the universe. Now I'm going to get into some numbers here.
Okay.
And some of these numbers, they're mind-boggling. Because we might say, I don't know if you ever played the lottery. I've never played the lottery because it's like, what are the chances of me getting the winning ticket? Well, that's not the only reason I don't play the lottery. But it's vanishingly small. Well, these numbers that I'm about to be telling you, they make the lottery a sure thing by comparison. So the density of the universe. So the density is how compact something is. So the universe is spreading out. It's getting to be less dense because it was packed in tightly and things are moving farther apart from each other. The density of the universe is fine-tuned that if it was different by 1 part out of 10 to the 17th, the 10 to the 17th is the number that you're like mind blown. That's a huge number.
How many zeros?
17.
Right.
That's the. So if the density 1 second after creation, okay, things are moving farther apart. If it was different than 1 part out of 100,000 million. So you add those zeros up and you get 17. Okay, a million is 6 zeros and a million would be 12 zeros. If the density was different than 1 part out of 10 to the 17th, then as it was spreading out, it wouldn't have had enough oomph to keep spreading out, and it would have collapsed on itself. And we wouldn't be here to even question how it could have happened. The next one, this one, it boggles my mind that we even know this. The mass of the universe. I scratch my head sometimes thinking, how do we even know the mass of the sun? Because you can't put it on a scale. But we somehow know the mass of the universe. And we, being the scientific community, I had no part in the measurements. I get to say I'm a scientist. First of all, the mass of the universe is 1.5 times 10 to the 53rd kilograms. Okay, so 10 to the 17 was 100,000 million. Well, this is a lot bigger than that. It is fine-tuned to 1 part out of 10 to the 60th. That if the mass was different, and this is crazy, if the mass was different, it says by the mass of a dime. So if there was a dime's worth of, and I say mass, but weight and mass are similar things. If there was an extra dime worth of mass, the universe would have been too heavy, and gravity would have taken over more than it does, and it would have pulled it back in. If the universe had been lighter by the mass of a dime, it wouldn't have been heavy enough, and it would have just flown apart. Right. We're talking about a dime, Jeff. Right. That was the tipping point. That's the Goldilocks of just right. Mind blown. There are several fundamental forces. Some of them we've heard of. Gravity. We've all experienced gravity. Electromagnetic. That's opposites attract and likes repel. Okay, we've heard of that one. So those are 2 of the 4 fundamental forces that most people have heard of. Then there's also the strong nuclear force and the weak nuclear force. The strong nuclear force. In the nucleus of an atom, we have protons and we have neutrons. Protons have a positive charge, neutrons have 0 charge. Okay, this is chemistry. This is yeah. Well, in the nucleus of an atom, all right, we know that opposite charges attract each other, but in the nucleus of an atom, we have protons and protons and protons. Why do they stay there? Well, there's some kind of attraction. It's called the strong nuclear force. And that force is also fine-tuned. Now, I don't have exponents on this one, but if it was weaker by only 2%, okay, that's not very much weaker, the force wouldn't be strong enough, and the protons wouldn't stick together. They would repel, and there wouldn't be anything heavier than hydrogen. Okay, on the periodic table of elements, again, that's a chemistry thing, hydrogen is the element that has only 1 proton. So if the strong nuclear force wasn't any stronger, if it was weaker by only 2%, then the only element in the universe would be hydrogen. And if it was too strong by only even 0.3%, then not only would the protons attract each other, but they would attract each other too well, and then we wouldn't have any of the light elements. I don't know how much you remember from biology class, Jeff. It's probably been a couple years. Well, the elements that life is really based on are the lighter elements. Carbon, hydrogen, oxygen, nitrogen, and those are all small elements. So if the strong nuclear force was too strong, then those light elements wouldn't exist because we'd have only heavy elements because everything would just it'd be like a big magnet, pulling things in. The electromagnetic force, okay, that's the one opposites attract. We know that one. Positive attracts negative. And so that one, if it was it is fine-tuned to within 1 part out of 10 to the 34th. If it was weaker, then electrons wouldn't stay, they wouldn't stay around the atom, okay? So we got protons and neutrons in the nucleus. We have electrons cruising around the nucleus. If the electromagnetic force was weaker, then the electrons wouldn't stay close. They would just leave. Well, chemistry is all about electrons moving from one atom to another atom. And so all the reactions that everything's based on wouldn't happen. If the electromagnetic force was stronger, then the electrons would never leave the atom. They would be stuck fast to the nucleus. And again, everything happens because electrons move where they need to go when they need to go there. And we wouldn't have, our body, there's chemical reactions going on all over the place all the time. The gravitational field, the gravitational force rather, okay? Gravity works, okay? Ever fall down the stairs? I did that too many times as a kid. Sometimes I got pushed. The gravitational force fine-tuned to 1 part out of 34, out of 10 to the 34. If the gravitational force was too small, then things wouldn't stick together. Things would fly apart. And like gases, our atmosphere, everything we breathe wouldn't stay here. It'd be gone. If it was too strong, then we said the universe is expanding, it's moving apart. Well, if gravity was too strong, it wouldn't be flying apart. Everything would come crashing back together, and we wouldn't be here. We would have gotten crushed. So those are the fundamental forces. And then actually even the ratio of this force to that force, those are fine-tuned also. The ratio of one force to the other, fine-tuned 1 part out of 10 to the 16th. The ratio of a different of those two forces, fine-tuned to 1 part out of 10 to the 40th. And again, now, and the scientists that are publishing these, now lots of scientists won't publish things that go against their worldview. And so lots of people have never heard these things. But, and some of the scientists who publish these things are Christians. But some of the scientists who publish these things are brave enough that even though they don't believe that God designed things, they're publishing these things and they're saying, it looks like it's somebody's cruel idea of a joke, that this is so fantastically fine-tuned. The energy, this one, the energy density of the universe, fine-tuned to 1 part out of 10 to the 120th. And I was reading this and they're saying, why do we even have these numbers? These numbers are so mind-bogglingly large that if you try to write it out, it's a 1 followed by 120 zeros. Right. But it has to be that. If it was bigger or smaller, then we would not be able to have life on Earth, but anywhere in the universe. Now, I've been talking about each of these things individually. But the probability of life, it actually is all of these numbers combined. So if you want to know the probability of tossing a coin and having it land heads up 10 times in a row, you take the probability of tossing the coin and having it land heads up once times the probability of it landing heads up the next time times and so you actually have to multiply all of these numbers times each other to get the probability of life. And it's incredible. One of these numbers is incredible, but to take the entire situation and then to have someone say, nah, maybe it happened by chance. Right. It's not going to happen. It's not going to happen. Now, some things that are more familiar to the people who are watching this. A little bit about water and a little bit about sunlight. Now, water is a crazy molecule. We don't oftentimes know how crazy it is because water is all around us. And we just assume that the way water acts is normal. But it's not. And I read that maybe we should call it H2, whoa, because of how crazy it is. We know the hot air rises because as you warm up the air, it gets less dense, and that's why hot air balloons work. Well, the opposite is also true. When you cool things down, they come closer together, they get more dense. So why does ice float? Because you're cooling the water down, and it's getting closer, it's coming closer together, closer together, closer together. But somehow, when it turns into a solid, it's not more dense. It's actually less dense. That's the normal thing for water, but that's not normal for almost anything else. What would happen if ice didn't float? Well, in the winter, lots of life would die because ice would not form at the top. Ice would, if it formed at the top, it wouldn't stay there. It would sink to the bottom, and then more ice would form, and more ice would form, and a pond would freeze solid. Everything in it would die. But as it is, it's like a protective skin, and it protects what's living underneath. It's like somebody's looking out for us, Jeff. The freezing point and the boiling point of water, they are, 32 degrees for the freezing point and 212 degrees for the boiling point. We think that's normal, I mean, if we've read up and know what they are. But water is a small molecule. The formula for it, H2O, there's only 3 atoms in it. Most things that have a small mass like that are gases at temperatures that we know. The oxygen we breathe in, carbon dioxide, those things are gases. But water is a liquid. If water behaved the same way as the other molecules that are the same mass, water would be a gas at the temperatures that we feel comfortable with, and there wouldn't be any water around to drink. And not only that, it wouldn't stay in our atmosphere. It would gone, and it would be like Mars. I don't remember if there's any solid, if there's any ice on Mars, but there's no water vapor. There's no liquid water. And so things that we think of as being normal for the water, it is normal for water, but only because water is such an amazing molecule. And it's a great thing that we have so much water on Earth because that keeps it nice and cool. You've been to the beach lately? Okay, so what the land temperature is doing, only 5 or 10 miles away at the beach, the temperature might be completely different because the temperature of the water is regulating the temperature right there. On a clear winter night when there's no cloud cover, it's incredibly cold because the water vapor in the air is like a blanket. It keeps the heat close to us. If we didn't have that, then it'd be like the moon. It's scorchingly hot during the day and so cold that you couldn't live there at night. Sunlight. The sun, so there's this thing called the electromagnetic spectrum. We know about visible light, that's what we can see, but there's also ultraviolet light, there's also infrared light, there's radio waves, there's X-rays, there's microwaves. The electromagnetic spectrum is it goes from really low energy to really high energy, and there's everything in between. The sun puts out energy at all of the wavelengths, low energy, high energy, but what is beneficial to us? Only a very narrow window, the visible spectrum, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. Guess where the sun puts out most of its energy? In that narrow window. Even though the sun gives off energy over the entire spectrum, over 70% of the light of the energy the sun gives off is in that narrow window that just so happens to be beneficial to us. That's where photosynthesis happens. And then another thing that is really kind of mind-boggling for some scientists. So most of our planet is covered with water. Sunlight, so water absorbs light, and water lets some light go through. The light that water lets go through is the visible light. It absorbs all the rest of it. And so things that are living under the water, the things that really would be benefited by the visible light, that's the light that makes it through. And again, scientists are looking at this and they're saying, okay, the sun could be putting off peak energy levels at any of the wavelengths, but it's giving off the peak energy at the visible spectrum. Water could be letting any kind of energy pass through. But the only energy that it's letting pass through is the visible spectrum. There's no reason that they would be the same narrow windows, except that maybe somebody's looking out for us. Somebody, and I'm just saying that facetiously, God's looking out for us. God set things up so that we could have life here on earth. The verse that I think of, the verse I thought of when you asked me about this, is Psalm 19:1. The heavens declare the glory of God. The skies proclaim the work of his hands. The thing I like most about all of these arguments is actually that it says nothing about the Bible. Because I have friends that don't believe the Bible. And so if I'm going to try to convince them that God loves us, that God set things up to benefit us, as soon as I open up the Bible, it's like, I don't believe that. So what else do you got? Right. But again, this is the argument, the fine-tuned argument that atheists scratch their head and they're trying to come up with an answer. And they say the only reason that they discount this is that they don't believe there's a God. They can't argue against the facts, the numbers, the measurements. They disbelieve that there's a God, and then they say, so it must not be true. Okay? If you come to it with an open mind, there's no other conclusion.
So again, as a scientist, the evidence clearly points to the fact that there is a creator, that there is God.
Yes, it does.
Thank you.
Certainly.